After we're done with Unit 1, we typically review within the classroom. So this is going to cover all the topics that we view in construction. So how to construct segments, how to bisect an angle, bisect perpendicular bisectors of segments, finding missing measurements, constructing triangles, types of triangles, and finding centers, pretty much running the gamut on here. On the review sheet, there's a whole bunch of vocabulary. I'm not big into vocabulary. I'm more into the being capable of performing the task that is given within the certain problem, finding the mathematical answer. So I tend to skip vocab in my review and get right into the nitty-gritty of performance-based questions. Like here with this problem, give you the segment K to M. Using this given array, construct the segment equal length to 2 times Km. This is a construction problem. They tell us right in it we have to construct. And whenever it deals with construction, we will always use the compass here. And basically what we want to do is we want to measure the distance from K to M. So I will put my bullseye end on one side and open the pencil to the other side, so that way there we have a good solid distance. So this opening here where my bullseye is equal to 1 length of Km, and we have to do 2 of Km. So I'm just doing this because it's easier, but I've opened it up, and what I'm going to do is I'm going to put my bullseye end on the end of our array here. And I am going to bring my pencil up, and I'm just going to make a little mark through. So there is 1 segment equal to 2 times equal to Km, and then I'll move my mark so that my bullseye is now on the intersecting point, and I will create another mark. I have now created a segment equal in length to 2 times Km from here to there. Distance is another thing we are usually tasked with find. Luckily for us, they give us a number line here, and they want us to find the distance of these different points. So distance from A to D, I see A is at -3, D is to 3. All we really have to count is from -3 to 3. So I count up, and I see the distance is 6. From B to C, B is at -2, C is 1, so we count up, and it is 3. And AB plus BD, well, A to B is just 1 from -3 to -2. And then B to D is from -2 to 3. That's a 5. So 1 plus 5 is going to give me 6. Here we need to write an equation, find the value of x. So this is labeling and creating an equation and then solving said equation. So we have point R between S and T. S to R is x squared. R to T is 13x, and S to T is 30. So we have 2 parts, and the whole is 30. So again, the whole is equal to the sum of its parts, so I'm going to add my 2 parts, part 1 being x squared, the other part being 13x, and I'm going to get the whole thing 30. So here we need to figure out what x is. There's no discernible way to figure out what x is because I have x squared, I have x, solid number, no way to really tell. This harkens back to the days of algebra where we have to use factoring, and in order to do that, our equation has to equal 0. So I'll subtract 30 from both sides, and we can't take 30 away from x squared or 13x. So we have x squared plus 13x minus 30 is equal to 0. So here's where factoring comes into play. We know if I were to break this up, I'm going to end up with 2 binomials. Some binomial times another equals 0. And what I have to do is I have to figure out what's going inside parentheses. So we know the first item in each parentheses when I use distribution is going to multiply to be x squared. The only way that happens is x times x. So x times x is going to give me that x squared. Now I need to figure out the 2 numbers that I'm going to put in to the parentheses. And fortunately for us, the problem is sort of hinting at what happens. So we know the numbers that we put in here are going to multiply, in our case, to be -30, and they're going to add to be positive 13. So we need to figure out what numbers are going to multiply to 30. So off to the side, I usually just list off factors of 30. So we got 30. 1, 15 times 2, 10 times 3, 6 times 5, and then we start rotating back around. So I got 4 possible pairs here to use. So I need to figure out which of these 4 pairs will somehow get me to positive 30, but multiply to add to positive 13, but multiply to be negative 30. The only way that I can get them negative is a positive times a negative. So 30 and 1, 30 minus 1 gives me 29, negative 30 plus 1 gives me negative 29, so that's not possible. 15 minus 2 does give me that positive 13, or negative 15 plus 2 gives me negative 13, so that's a possibility. 10 and 3, 10 plus 3 gives me 13, but remember one of them has to be negative, so if I do 10 minus 3, I get 7, or if I did negative 10 plus 3, I'm going to get negative 7, so that's not possible. 6 and 5, I'm not going to get 13 either. So I'm going to be using 15 and 2. One's positive, one's negative. Question is, which one's positive? Well, the middle term is positive, so this means the bigger of the 2 numbers I picked is also positive. So 15 is positive, 2 is negative, 15 minus 2 gives me 13. I can split these up, and I will set each of these equal to 0. So x plus 15 is 0, and x minus 2 is 0. Solve for x, I'll subtract 15, so we get x equals negative 15. And on the other side, I'll add 2, so x ends up being equaling to 2. So here we have 2 possible values of x, negative 15 and 2. 37, it's the same deal. We label what we can and figure out x based on what we were told. I'll skip that one because it's the same as the previous problem. 38 here, line K bisects LM at point P. We are told the length of LP and what PM is. Same deal. Bisect means cut in half, so L to P is equal to PM. So I will take 16x minus 34 and set it equal to 8x minus 10, solving for x. This next problem, we have to figure out the value of x. This time we're talking about angles. We have AB perpendicular to CD, where they intersect at point E, and we are told angle DEA is 5x minus 15 degrees. So this upside down T means perpendicular, and perpendicular lines create 90-degree angles. So this angle here is 90-degree angle, 90-degree angle, 90-degree angle, 90-degree angle. So they're all right angles, which means DEA is a right angle, therefore 90 degrees. So 5x minus 15 gives me 90 degrees. I'll solve for x by adding 15 to both sides first. So we get 5x gives me 105. Divide by 5. And we get x equaling 21. So we found the value of x in this particular case. Number 40, little bit of definition. We're not really going to go over this. Equidistant, so perpendicular bisector. Again, bisector cuts it in half. So that means every point on the perpendicular bisector is going to be the same distance from the endpoints of XR. So 3 points equidistant from X to R. Well, obviously point T is here in the middle, and then P is up here, and Q is down there. So they're all going to be equidistant. So if I were to measure from X to Q, it's going to be the same as Q to R. If I were to measure from X to T, it's going to be the same from R to T. And same with X to P and R to P. It's going to be the same distance if I were to take a ruler and measure the distance. Another one where we have to find the value of x given a figure here. We have BD bisecting angle ABC. They tell us that ABD, so from A to B to D, is 3x minus 7 degrees. And angle ABC is 40 degrees. So the whole thing here is 40. we need to figure out what x is. Well, if BD bisects the angle, then that means it's cut in half. So the part that is 3x minus 7, well, if the whole thing is 40, then this top half is only going to be 20 degrees, and this bottom half is also 20 degrees. So 3x minus 7 is going to be equal to 20. And this is for a. So 3x minus 7 gives me 20. Solve for x. I'll add 7. We get 3x equals 27. Divide by 3. X gives me 9. And we can do that same philosophy with the other two, which I can cover in class as well. 42, now we start getting back into constructions a little bit. It says construct the perpendicular bisector of segment CD. So construction means we need our compass. We have to measure the distance for a perpendicular bisector. So bullseye on point C, pencil on D, and we just make a swoop around. And then I'll swap the sides. So I'll put the bullseye on point D, pencil on C, make another swoop, and we look for the intersectings of our two arcs, and I will just draw a straight line through those two intersecting spots. Perpendicular bisector. 43, we are asked to construct the circumcenter of this triangle. So in class, we talk about circumcenter and incenter, and the question becomes, how do I figure out which construction I have to do? Because when it comes to circumcenter or incenter, I actually have to use either the perpendicular bisector or the angle bisector. So the question becomes, how am I supposed to remember? Well, circumcenter begins with C, which is a consonant. So I look at perpendicular bisector versus angle bisector, consonant, consonant. So I'm going to be doing the perpendicular bisector. Technically, we're supposed to be constructing the bisector of all three sides, but it gets kind of redundant since 2 sides is all you really need, because you want to know where the perpendicular bisectors will cross. So I need to make my triangle here a little smaller. So again, perpendicular bisector means my bullseye goes on one point and my pencil goes on the opposite point of the side that I'm using. So here I'm using side KM, bullseye's on point K, pencil's on point M. So just like in the previous problem, I'm going to make a nice giant swoop around that point. Once I'm satisfied, I'll swap it. I'll move the bullseye to point M, pencil to point K. Once I'm happy, I'll make another swoop. And I look for points of intersection. So here I see I have 2 points of intersection, and I'm going to draw a line through those 2 points using my ruler. So that's one line. That's one perpendicular bisector for K to M. Now I need to pick one of the other sides, either K to I or I to M. I will use side IK. So same thing as before, bullseye on one point and pencil goes on the other. And once you're happy with where your pencil and endpoint are, I'll use a different color on this one. You draw a swoop, and then you'll swap it. So that way your bullseye is on point K. pencil is on point I. Once you're happy, you make a mark. And notice now my green arcs have 2 points of intersection, so I'm going to draw a line through those. And where my green and blue lines cross, I'm going to put a little point and label it P. Therefore, that is the circumcenter, creating the perpendicular bisector of the sides of the triangle. 44, we have to find the bisector of this angle D. Again, construction means we need our compass. And this one's a little bit different. So perpendicular bisector, we need to measure the distance from one endpoint to the next. When it comes to an angle bisector, it's a little bit different. We still need to know distance between 2 points, but at this point, we don't have the 2 points that we're looking at. So when it comes to angle bisector, I'm going to put my bullseye end on the vertex of our angle, and I'm going to open my compass up however far I want. And all I'm going to do is I'm going to make a swoop through the angle. So we have 2 points where an arc crosses. This is the distance that we're going to be measuring. So we're going to be measuring across the angle here. So this means endpoint on one side of our angle, and then I'm going to rotate my pencil around so that it's on the other side of the angle here. And once I'm happy with where it's at, I'm going to draw an arc out into the angle. And then just like before, what I do to one side, I have to do to the other. So I'll move the bullseye over, in this case, to the bottom, and pencils on the top section. And once I'm happy with my placements, I will draw an arc out into the angle. And notice we have a crossing point. That is the point that we are going to run our line through. So we start at the vertex and run through that fancy looking X. So this is the angle bisector. And I can use that to find the incenter of a triangle. And just like before circumcenter, I use the perpendicular bisector. The incenter, I'm going to use the angle bisector. So again, I have 3 different angles to work with. I need to find out where 2 of my angle bisectors cross in order to figure out where the incenter is. So construction-wise, we'll use our compass. And we can use any of the 3 angles. So again, bullseye, I'll start at point K. I'll open it up as far as I want. In this case, I'm happy right here. I'll mark a swoop through, so now I can measure across the angle here. So I will put my bullseye end on one spot that crosses the side. In this case, I'll start on the point that crosses line side KI. I will open up the pencil so it's on the intersecting spot on side KM, and I'll mark out into the angle. And then I'll switch sides. I'll put the bullseye on side KM and open the pencil so it's on side KI. And I'll open up out into the angle. So here we got the we have the intersecting arcs. I can draw a line using my ruler straight through. So there is one of my angle bisectors. Next up, I'm going to pick a different angle. I'll use M, because why not? And just like before, I am going to put the bullseye end on the vertex, in this case point M, and I'll make a swoop through. So now I have a distance measurement across the angle here from point M. So I'll put my bullseye on, in this case, the bottom part, and I'll rotate it so that my pencil is on the other side. And I will mark out into the triangle in this case, and then I will swap it again. So now the bullseye is on the top side and pencil's on the bottom. I'll mark out into the triangle and I got this fancy looking X. I can use this X as a marker to draw a line through the intersecting spot. So I have found the angle bisector at vertex M, and where my green line and blue line cross is the incenter of the triangle, and I'm just going to place a little dot where they cross and label it point P. Number 46, we're going to construct an angle on EL here that is congruent to angle M here. So we are going to be copying the angle really. So what we have to do is pretty much very similar to what we do with an angle bisector. So construction means compass comes out, and what we want to do is we want to place our bullseye on the vertex on M, and we can open our compass up as far as we want. Doesn't really matter. And we are going to mark it through. So notice it went marked through. I'm going to bring my compass down, place it on point E, and I'm going to make a nice giant swoop on point E. Now, in order to figure out where I have to put my top side, what I want to do is I want to measure the distance. Again, we want to measure the distance across. So we are going to put our bullseye on the intersecting point on the bottom side, and we are going to put our pencil on the top side, pencil on our intersecting point, and we're just going to make a little mark through. And we're going to bring our compass down. My bullseye will be on the bottom part of the ray here, so ray EL. Pencils should already be set as long as I didn't move it. And I'll make a little mark. I now have a point of reference, so I can draw a line starting at point E and running it through where the two lines cross. And I have now copied angle M. Here we're tasked with finding the equilateral triangle. Here we have segment CD. And to create an equilateral triangle really isn't that difficult. It's pretty much the same as finding perpendicular bisector. So to construct, we put our bullseye end on point C, and we're going to open it to point D, and we're just going to make a swoop around. And we will, once you're set, we'll swap it. Now our bullseye is on point D, pencil is on point C, and we'll make another swoop. What I now have is I have two reference points. So instead of drawing a line straight through like we would a perpendicular bisector, I can use either of these points of intersection as the third point of our triangle. So if we use the top side, CD, we'll label it E, and I will connect C to E and D to E. So there's an equilateral triangle. If I wanted to use the one on the bottom, I would have put a point down here. We can say this is point F, but I would have done the same thing. I would have drawn a line from C to F and F to D, and there's another equilateral triangle. So either way, you have two equilateral triangles in this particular case. 48 here, we have to classify each triangle based on its angles and sides. So we have to look at what we're given. Triangle ABE. So this triangle here is the one we're looking at. Start at A, go to B, go to E. So there's the triangle. So I have to look at the markings. So based on angles, I take a look. I see I have a right angle in corner where A is. So based on its angle, we can say it's a right triangle. And if I look at the sides, I see I have one marking, one slash and one slash here, and two slashes on the bottom. These two slashes here tell me that these two sides are the same, but this third one is not. So two sides the same means we have an isosceles triangle based on its sides. Now we have to classify triangle EBC, again based on its sides and angles. So if I look at EBC, so E to B to C, the big one here, I see we have angle 75, 75, so that's 150. Angles of 15 and 15, and two slashes on these two sides. So two sides the same, again, means isosceles triangle. And angles of 150 means we have an obtuse triangle based on its angles. And last but not least, we have to find what kind of triangle BDC is. So we have triangle BDC. We have a little square in the corner, meaning we have a right triangle. And if I look at the sides, again, 90-degree angle, 15-degree angle, 75-degree angle, all angles are different. So that means all sides are different, meaning we have a scalene triangle. All sides are different. Here we are tasked with finding X, equilateral triangle. We could draw a picture. Equilateral triangle means all three sides are the same, so we can pick any two sides to set equal to each other and solve for X. Same with 50. Isosceles triangle tells us which two sides are the same, so set those two sides equal to each other, solve for X. Same with 51 and 52. Find the value of X. Again, using our hints, they tell us all three sides are the same. So to find the value of X, since all three sides are the same, or rather all three angles are the same, that means all three sides are the same. I would set the two easiest sides, in this case 7x minus 7 and 5x minus 1, I would set them equal to each other to solve for X. And that is review of constructions, types of triangles, and different definitions.